Here is a graphical representation of depression in freezing point of a solvent when a solution is prepared by dissolving a solute in it. The orange line represents Tf, that is, freezing point of the solvent, while the blue curved line represents T-F, freezing point of the solution. Tf and T-F are the temperatures in Kelvin. Obviously, therefore, depression in freezing point delta Tf is equal to Tf minus T-F. So now, just as we have determined a expression that lowering of vapor pressure, similarly we can determine and find out an expression, evolve an expression for depression in freezing point. Now, what do you mean by depression in freezing point? Again, it is a colligative property, and freezing point depression is represented by delta Tf. Delta means change in temperature of freezing point. Now, freezing point is depressed. That means it is reduced. Therefore, the freezing point of the solvent, which will be represented by Tf naught, will be more than freezing point of the solution, that is Tf. So delta Tf is represented is equal to delta Tf naught minus Tf. Naught means solvent or liquid, pure liquid. And we know that delta Tf is proportional to the molality, M. M means molality. And therefore delta Tf is equal to, if you remove this proportionality, then you have to put up a constant, and that is Kf. So delta Tf is equal to Kf into molality of the solution. Molality means the number of moles of the solute per kg of the solvent, per kg. So this is, we can say that delta Tf is equal to Kf into M, capital letter M, small letter m. And wherefrom you can find out M is equal to W2 upon M2 divided by W1 upon 1000, because it is per kg, weight of the solute per kg of the solvent. So that is there. And this Kf has been given its own name. It is known as freezing point depression constant, or we call it as molar depression constant. This is also known as cryoscopic constant. So finally, on simplification, we get delta Tf is equal to Kf into W2 into 1000 upon M2 into W1, small letter W1. And therefrom, we can find out that M2, the best advantage of this expression is that we can calculate the molecular weight of the solute, M2. M2 represents the molecular weight of the solute. And M2 is equal to, on simplification, you get this expression, that Kf into W2 into 1000 upon delta Tf W1. And delta Tf is known to us at a particular temperature for a particular solution.